Okay, so today we're going to talk about the laws of motion. Here we go. Sir Isaac Newton's laws of motion. And there are three, and here they are. The first law states an object at rest remains at rest, or an object in motion remains in motion unless acted upon by a force. That means an object at rest will continue to stay sitting still or at rest unless something comes up and causes it to move. Or an object in motion is going to stay in motion. That means an object that's moving around is going to come to a stop if a force comes in and causes that to happen. The second law is dealing with his mathematical findings, and it states that the acceleration of a body depends on the ratio of the acting force to the mass of the body. And that law, the mathematics behind it, is force equals mass times acceleration. And basically what he's saying with this is an object can accelerate, and it depends upon its size, how much mass is in there, and how much it's being accelerated. You know, a big truck is a lot harder to get it going, but it has a lot of mass. Okay, but once you get it going, then it builds up with that momentum, so it kind of plays in there. The third law deals with action-reaction. For every action, there is an equal opposite reaction. That means if something moves forward, there is a force that pushes it backwards. Okay? So let's take a look at each of these more in depth. The first law is called the law of inertia. And again, now inertia is basically called the force that is resistant to the direction of motion. A good way to put this are these seat belts this couple is wearing in their car. By having those seat belts on, and we'll call them inertia belts, basically it locks them in and prevents them from moving forward. So it's a force that is resistant. So if you lock yourself in with the seat belts and you come to a sudden stop, your body typically wants to move forward, but those seat belts lock you in and prevent you from moving forward. And this poor gentleman up in this diagram up here, he didn't have his seatbelt on, so when the car comes up, hits the wall, he's thrown out of the car. Or the little skateboarder down here, the skateboard comes to a sudden stop, but his body continues to move forward. So there was nothing there inertia-wise to resist that actual motion. This right here is called unbalanced forces, okay, because you typically will either remain in motion or you will come to a sudden stop with this particular law. Okay, our example again are seat belts, which we're now going to call inertia belts. Now the second law again is dealing with his mathematical findings, force equals mass times acceleration. The concept here is dealing with acceleration of objects, but also this is also unbalanced. That means we're going to always have something moving. Remember we said if it's balanced, it's probably not going to move. Examples of this would be hitting a golf ball gently versus hitting it really hard to go a particular distance. So in here, we're going to actually practice the force equals mass times acceleration. So here we have a particular situation, force equals mass times acceleration, but I also call it force equals ya mama, M-A for your mom. Okay, so here is your mass of the object. It's 1,000 kilograms. And remember, mass in this instance will always be in kilograms. And then there's your acceleration, meters per second, or meters per second squared. So you take the two numbers and you multiply them together, 1,000 times 0.05, mass times acceleration. And what would you get? Okay, try it on your calculator and figure it out and add it to the paper. Okay, the third, and here again with the second law of motion, again, force equals mass times acceleration. If you set it up here, notice mass and acceleration are on the bottom and force is on top. Okay, remember side by side you multiply. So here we have three problems that I want you to try at your seats. The first one says how much force, that means we're solving for F, is needed to accelerate a 500 kilogram car, that's your mass, at a rate of 4 meters per second squared. That's your acceleration. So here we have mass, here we have acceleration. What do you do to the two? Okay, figure it out based on this triangle and come up with your answer. Write it down, let me check it. The second problem says 100 Newton causes an object to accelerate at 2 meters per second squared. What is the mass? So here we're solving for mass. 100 newtons, that newton is a unit for force. So on here, that is a force right here, and it's going to cause an object to accelerate at 2 meters per second squared. So we have a force up here, we have an acceleration, one on top, one on the bottom. Come up with your answer, let me check it. And the last one, we got a 1.5 kilogram ball. Kilogram, that's your mass right here, is kicked with a force of 450 newtons. So this is up here, 450 newtons. What is the acceleration? And remember what each of the units are. So figure it out, come up with your answer, and let me check it. Here's some more examples. These are not listed on your paper, but let's check this. The first one says, how much force is needed to accelerate a 2,000 kilogram car at a rate of 4 meters per second squared? Here you have mass, here you have acceleration. Look, going back to the previous slide, figure out what do you do? Do you either multiply or divide those two numbers together? Okay, and remember you're solving for force. For problem 2, a 50 kilogram object is accelerating at a rate of 2 meters per second squared. What is the force that causes this to accelerate? So again, mass, acceleration, calculate it. Raise your hand if you want me to check over your work. Okay, the third law of motion is dealing with action-reaction. For every action, there's an equal and opposite reaction. And this is the only one that is balanced. Examples of this would be a stationary object, something sitting on your desk. Or looking at this one, the Newton's cradle here. You have a force coming in and it causes it to move out. Or better yet, I love this one, the rocket right here. The force is pushing downward, it's moving upward. Okay, this is also a little steam engine. The steam is blowing out this way, but it's going to move in this direction. Or a gun. You're forcing it in, the action is causing the bullet to be projected. Okay? Here again is applying the third law of motion. If Rico kicked a ball with 100 Newton force, how much force did he exert? If Rico kicked a ball with 100 newtons of force, how much force did the ball exert back on Rico? If he's put in 100 newtons, how much is coming back on him? This is dealing with the third law of motion. Okay, and that is it for today. Tomorrow we'll talk about gravity, free falling, and weight problems.